Welcome to this class. We want to learn how to determine the probability when a die is rolled or when two dice or multiple dice are rolled. Now, the first thing to do, like we explained in the previous lessons, is to draw the probability table. And this is how the probability table looks like when two dice are rolled. I say that to draw this, you arrange the sides of each of the die in vertical and horizontal pattern. Since we have only two dice and a die has 6 sides numbered from 1 to 6, so we pick the first one. We say 1, 2, 3, 1, 2, 3, 4, 5, 6. We take the vertical line to represent the first die, and then the horizontal line to represent the second die. So you can do it on top and say 1, 2, 3, 4, 5, 6. Now this represents the two dice we've rolled. Now to get the outcomes from these two dice, we combine each one from the horizontal and another one from the vertical. That is one on top and one here. So if you pick the first line, that is number 1 here in the vertical, we combine it with the first one in the up, combine it with the second one, combine it with the third one until we get to the number 6. Then we pick 2, we continue doing it. Each one we write the one in the vertical first and then write the one in the horizontal second. For instance, if you pick 4 and we combine with 1, then we have 4, 1. If we pick 4 and combine it with 2 in the horizontal, we have 4, 2. Or you can just write 4 and put a space and write the second one. So you continue doing it like that until you get to 6 and you complete the number 6 also. So this is how to create the probability table when two dice are rolled. Now the questions they can ask us from the probability table of rolling a die or dice include this. We may be asked to find the probability of getting maybe 6. That is, you get 6 in the first row and you get 6 in the second row. If you are asked this kind of question, you come to the probability table you've drawn and look for the one that you have 6, 6 or 6, 6. That determines the one that you have 6 in the first row and 6 again in the second row. So you check your table one by one. You look for the one that is 6, 6. This is the one that is 6, 6 here. Let me use this color. So this one is the only one that is 6, 6. And that shows that you have 6 in the first row and have 6 again in the second row. So since if you calculate all these, you are calculating from this. Remember, you are not counting these parts if you want to count the total outcome. These parts, they are out. So you calculate everything from here to here. And then inside, if you check everything, it's going to be 36. That is 1, 2, 3, 4. You count it to this place. everything is 36. That is 6 times 6. Now, we now say that out of 36 outcomes, we have only one that is 6, 6. That is 6 in the first row and 6 in the second row. Now we say that the probability of getting 6, 6 is 1 out of 36, which is 1 over 36. So that should be the answer to question number 1. 6 in both the first and second row is 1 over 36 because there is only one outcome that has 6 in the first row and 6 in the second row. This 1, 1 means 1 in the first row and 1 in the second row. 1, 2 means 1 in the first row and 2 in the second row. 1, 3 means 1 in the first row and 3 in the second row. 6, 3 means 6 in the first row and 3 in the second row. They can ask you what is the probability of getting 4 in the first row and 5 in the second row. You come to your table and look for it. 4 in the first row, that is this one, and 5 in the second row. You check if there's another one that you have 4 in the first row and 5 in the second row. And if there is, you count the total number of them, and that represents the outcome, and then you divide by the total outcome, that is the sample space. So we have only one here, which is now again 1 over 36. Now the second question here could be, they can ask us the probability of getting 2 in the first row and 3 in the second row, just like the one we've done before, 4 and 5. So 2 in the first row and 3 in the second row, that is this one. Do we have another one like that? No. So we have 1 over 36 also. Then the probability of getting 5 either in the first row or the second row. Now this means the probability of all the outcomes that have 5 in them. So whether the 5 comes in the first row or it comes in the second row, we count it. So we go back to the table, we check the ones that anyone that has 5, it is among the outcomes. So we look in the first line, no 5, second line, no 5, third line. Okay, so we have here, we have 5 here, 5, 1. So 5 is in second row here. So we have 1, 2, 3, 4, 5, 6. Then we come to this side. We have 5 here. We have 1, 6, 7, 8, 9, 10. We've counted this one. Then 11. So we have 11 outcomes that have 5 in them. The 5 is either in the first row or in the second row. So we say that the probability of getting 5 either in the first row or the second row is 11 over 36. Now the probability of getting a total of 9, it means that we come to the table and check the one that we check the outcome in the first row and the outcome in the second row, and when we add 2 of them, it is going to give us 9. So we come here from 5. Let's start from 5. 5 plus 1, 6. 5 plus 2, 7. 5 plus 3, 8. 5 plus 4, a total of 9 is 9. 5 plus 4 is 9. Okay, let me clear this first. Now 5 plus 4 here is 9. The total here is 9. Now we also have 5 plus 4 is 9 here. Any other thing that can give us 9? 6 plus 3 will give us 9. 3 plus, let's come to 3. 3. 3 plus 6 will give us 9. So this 3 plus 6 here will give us 9. 3 plus 6 here will also give us 9. Then we come to 5. 4. Let's come to 4. 4 plus 5 will give us 9. Yes. And 4 plus 5 here will give us 9. Now let's come to 5. 5 plus 4 will give us 9. In the vertical, 5 plus 4 give us 9. And 5 plus 4 will give us 9. Okay. Then 6. 6 plus 3 gives us 9. And 6 in the other side. 6 plus 3 also give us 9. So we have total of 1, 2, 3, 4. We have 4 numbers, 4 outcomes that will give us 9. So we have 4 over 36. 36 divided by 2, we are going to get 18. So 18 over 2, which will give us 1 over 9. So if we simplify everything, we get 1 over 9. So that is a total of 9. Then a total of 11, you do the same thing. You look for the one that when you combine the first outcome and the second outcome, you are going to get 11. Total score that is greater than 8. Total score that is greater than 8, you come to the table. You look for the numbers that are greater than 8. Let's pick the first line, 1. 1, the highest number there is 16. So it is 7, which is not even up to 8. But we are looking for the one that is greater than 8 if we add 2 of them. Then we come to 2. The last number there is 26. That is the highest number there. 26 is 8. But they say the number that is greater than 8. So this one is not among. Now we come to 3. The highest number there is 36, which is 9. So it is among. So we have 3, 9. We move to the highest number first, which is 3, 9. Then we check if the one at the back of it is also, which is the second highest number in the row, which is 3 and 5. 3 and 5 is 8 and not more than 8. So we are not counting it because it is not more than 8. Now we come to this fourth row. The highest number there is 4 and 6, which is 10. 10 is more than 8, so we count it. Now the one at the back of it is 4 and 5. 4 and 5 is 9, so it is also more than 8, so we count it also. Then at the back of 4 and 5 is 4 and 4, which is 8. And we are looking for the one that is more than 8, so we are not counting 4 and 4. Now we go to the fifth row. The highest number is 5 and 6, which is 11. We count it. The next one at the back of it is 5 and 5. It is 10. We count it. And the next one is 5 and 4, which is 9. It is also more than 8, so we count it. Then at the back of it, 5 and 3 is 8, not more than 8, so we are not counting it. Now we go to the last row. We have 6 and 6, which is 12. We count it. We have, at the back of it, we have 6 and 5, which is 11. We count it. At the back of it, we have 6 and 4, which is 10. More than 8, we count it. At the back of it again, we have 6 and 3, which is 9. more than 8, we also count it. And at the back of it, we have 6 and 2, which is 8, not more than 8. So we are not counting it. So that is the whole numbers that are more than 8. So we count all the outcomes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 over 36. 10 over 36. 10 over 36, so which we then simplify again to get 5 over 18. So 5 over 18 is the answer. That is the total number that is greater than 8 in the table. Then they can ask us, okay, we answer this one. Now they can also ask us the total number that is less than 6. We also use the same way to look for the ones that are less than 6. And then the total number that is even number. For even number, now see what we do. Total number that is even. Even numbers are numbers that are divisible by 2 without a remainder. So we add the first row and the second row and check if it is even, if it is divisible by 2. The first one, let's start from row 1. 1 is 2. 2 divided by 2 is 1 without any remainder. So 2, the first row here is even. Then 1, 2 is 3. If we divide 3 by 2, we have a remainder, so it is not among. 1, 3 is even. 1, 4 is 5. 1, 5 is even. 1, 6 is 7. Then 2, 1 is odd. 2, 2 is 4, is even. 2, 3 is 5. 2, 4 is 6. 2, 5 is 7. 2, 8, 2, 6 is 8. So we continue doing it like this until we get to the last even number, and then we count the total outcomes that are even, and then we write their probability. Then they can also ask us the total odd number. We follow the same step and get the total odd number in that table. So this is actually how to solve probability that involves rolling 2 dice by constructing the probability table for the event. I hope this is very clear. Thank you.